Hello, this is Coach Meinbauer, and we are in AP Pre-Calculus Learning 2.1, Change in Arithmetic and Geometric Sequences. So here we go. So we're going to be learning about sequences. There's two types. There's arithmetic, which is very similar to having like a linear equation, and geometric sequence, which is similar to an exponential equation. So I'm going to first focus in here on the arithmetic sequences. So two different forms that we use for arithmetic sequences. There's going to be this a sub n equals a sub 0 plus dn. So n is our variable here. So it's really means that the initial term, very initial term, plus their difference times n, whereas d is our common difference, which is the difference between the two sequences. A sub 0 said is the initial value, and a sub n is the value of the nth term. The one that we're probably going to use more, though, is this one right down here. Okay, and I'm going to put some meaning to this as we go. So a sub n equals a sub k, where a sub k is the kth term, plus d n minus k. So really, arithmetic sequence that we're given here is 3, 9, 15, 21, 27. Okay, this is an arithmetic sequence because if you notice, it either increases or decreases by the same amount every single time. So to go from 3 to 9, that's plus 6. Go from 9 to 15, it's plus 6. So these are arithmetic sequences whenever we have the same type of difference between the numbers. In this case, it's 6. So the common difference here is d equals 6. Now, we're going to write an expression for the nth term. Okay? It should be a D. This kind of looks like I don't know what that looks like. Okay, so the nth term. I'm going to go ahead and use this top one right here for number 1. Okay? So a sub n. What is going on in the world? Oh, boy. Here we go. A sub n is equal to, I'll find a sub 0 in a second, plus 6n. A sub 0 is my 0 term. So 3 is my a sub 1. A sub 2 is my 9. A sub 3 is my 15. You get the idea. So my a sub 0 term is, if I go backwards here, that's minus 6. If I go backwards here, that's minus 6. So a sub 0 is if I go backwards 6 more. So if I go backwards 6 more from 3, I'm going to get negative 3. So my a sub 0 term is negative 3. Okay? Now using this, let's go ahead and find a sub 10. So what I'm going to do is I'm going to plug in a 10 for my n term. So I have negative 3 plus 6 times, not n anymore, but 10. I'm going to get 57. Okay? Example 2. The fourth value, a sub 4 of arithmetic sequence, is a value of 14. The common difference is 6. What is the 10th term of the sequence? Okay, so here for this one, because I have some type of value, I'm going to use this bottom one right here because I have the fourth value. So since a sub 4 is equal to 14, and the common difference d is equal to 6, I'm going to use the a sub n equals a sub k, which is going to be a sub 4, plus d times, just kind of remind you back up here, it's d times n minus k. So the n is my variable, n minus 4. Okay, let's plug in everything that we know. A sub n equals a sub 4, which is 14, plus 6, n minus 4. So that is the nth term. Now using that, what is the 10th term? So when n equals 10, here we go. A sub 10 equals 14 plus 6, 10 minus 4. Okay, this is going to give me an answer of 14 plus 6 times 6, which is 36. It gives me an answer of 50. Okay? So that is arithmetic sequences. Okay. I'm going to go ahead and talk about geometric, and then I'll kind of talk more complicated down here with these other geometric sequences. So geometric sequence is where we now have a ratio, so something's being multiplied by itself over and over again. So same thing, there's two things that we want to know. We want g sub n is going to be g sub 0, r to the n. R is the common ratio. G sub 0 is the initial value, and g sub n is the nth term. Or we can use this one down here, which is easier if I'm only given one term or two terms. Okay. So for this first one right here, given the geometric sequence, 2/3, 2, 6, 18, it's to figure out what are we doing to multiply. Now, it's easier to do some of these, like 2 to 6. I know that's times 3. 6 to 18, that's definitely times 3. So these are all times 3. 2/3 times 3 is 2. So the common ratio here is 3. So what's the nth term? I'm going to use this top one again, g sub n is equal to, I'll figure out the g sub 0 in just a second, but this is going to be times 3 to the n. Now, what's the g sub 0 term? We're gonna go backwards like we did on the previous one. So if I have g sub 1 is 2/3, g sub 2 was 2, g sub 3 was 6. So going backwards, we're dividing by 3. Backwards dividing by 3. So we have to go backwards, divide by 3 to find the g sub 0 term. So if I divide that by 3, I'm going to get the same thing as multiplying by 1/3. G sub 0 is going to equal 2/9. So this is going to be 2/9. That's used to find g of 5. So g of 5 is equal to, plug in a 2/9 times 3 to the 5th, 3 to the 5th. Well, I do know that on the bottom there, this is 2 over 3 squared. So, and this is 3 to the 5th. We do know about our exponent laws. This is just going to be 2 times 3 cubed, which is 54. So we use a little bit of our exponent properties that we have learned from previous classes here. Okay. Next problem, the second value, g of 2, geometric sequence has a value of 8. Common ratio is -2. What is the fifth term of the sequence? So I want g of 5. So real quick, let's find g of n. And since I only have two things, or one thing rather, I have the r and the g sub k. I'm going to use this one right here, the bottom one. So g sub n is going to be equal to g sub 2 times r, which is -2, okay, to the n minus k. So in this case, n minus 2. Which g sub 2 we know is 8. So it's going to equal 8 -2 to the n minus 2. So I'm looking for the fifth term of the sequence. So g sub 5 is equal to 8 times -2 to the 5 minus 2, which is 8 times -2 to the third, which is -64. Okay. All right, let's go ahead and do this next arithmetic sequence question. This one gives us two values, and we're going to find a sub 14. So given these two values right here, I'm going to use this equation right here, this bottom one, a sub n equals a sub k plus d. So I'm going to write it right here just so I have it. A sub n equals a sub k plus d n minus k. Okay, to find a sub n, what I'm going to do here is I'm going to let a sub 9, the larger one, equal a sub 4 plus d n minus k, which I said k is 4. Okay, I'm going to do this to help me find the d value because I don't have that. So a sub 9, which is 45, equals a sub 4, which is 10, plus d n minus 4. Okay. So for this one, actually, I plugged in a 9. I am a little bit ahead of myself, or behind. The n value, I plugged that in. Sorry, it should be 9. All right, so this is going to be 9 minus 4, which is 5. So I'm going to n equal 9 on this one. And then k equals 4. That's where all that stuff comes from. So now 35 equals 5d. D is equal to 7. So a sub n is equal to a sub 4 plus 7 n minus 4. We can plug in our a sub 4 value, which is 10 plus 7 n minus 4. This is a totally 100% correct answer. I'm good with it. If you want to rearrange it so that you can multiply the 7 times n, you totally can, but this is a perfectly fantastic answer. Let's find a sub 14. It actually makes it a little bit easier to find this in this form. So a sub 14 is going to equal 10 plus 7 times 14 minus 4. And that's going to give me 10 plus 70. So the answer here is 80. All right. Same idea. Now let's go ahead and do the geometric one. So g sub n. G sub n is equal to g sub k r to the n minus k. Okay, so for this one, I'm given g sub 3. So let's go ahead and use n equals 6. Use the n equal 6 larger number. So that way we can use k equals 3 to solve for r. So if we do that, we're going to do g sub 6 equals g sub 3 times r to the 6 minus 3. So g sub 6 is 18 equals 3 r to the third. Okay. Oh, this number turns out to be nasty, doesn't it? It does. So we're going to get r cubed to equal 6. Okay. So r is equal to the cubed root of 6, which is the same thing as 6 to the 1/3. Okay. So g sub n is equal to, I'm coming right back to g sub 3 times 6 to the 1/3 times n minus k, which is 3. So let's just rewrite this out now. G sub n equals g sub 3, which is 3. And this is 6 to the 1/3 n minus 3. I've seen that written like this as well. If you want to write it as 3 times 6 to the 1/3 n minus 3. Same thing, okay? So if I want to find g sub 2 using this, I'm going to go ahead and plug in a 2. So it's 3 times 6 to the 1/3 of 2 minus 3, which gives me an answer of 3 times 6 to the negative 1/3. And I'm just going to leave the answer just as that. It's a totally fantastically awful answer, but it's the answer that we got here. Okay. Last thing is talking about graphs and of sequences in geometric. This is a arithmetic sequence graph here. You can tell because we're increasing by the same amount every time. So it wants me to write an expression for each sequence. You can kind of see how I am going. You can see how that makes a line right there, right? So essentially, I want to go backwards and find my, what are we doing over here? Go backwards and find my a sub 0. So my a sub 0 term looks like it's negative 14 because it looks like because the d value it's increasing by 2. So a sub n equals negative 14 plus 2n because we're increasing by 2 every time. Okay. The geometric one, this one is just difference. It looks like we go to 5 and then we go to 1 and then something underneath it. Kind of hard to tell as we get down there. But our r looks like we're going to multiply by 1/5 because it got from 5 to 1. You have to multiply by 1/5. Okay. So g sub n for this one is going to be, well, if we're divided by 5, I need to find my g sub 0. I'm going to be increasing. So it's the opposite. So g sub 0 is going to be 25. It makes sense because if I take 25 divided by 5, I'm going to get the g sub 1. So I'm going to get 25 and then 1/5 to the end. All right, and that is going to conclude our notes here on sequences for arithmetic and geometric sequences. Do not forget to like and subscribe.